This lesson is calculating the greatest common factor of a polynomial. So when we talk about a polynomial, let's look at what a polynomial looks like first. 12x to the third plus 9x plus 3 is a polynomial. We've got three different monomials, so we've got three different terms. We're adding them together. So any combination of adding and subtracting of different terms is going to be working with a polynomial. So what we want to do today is we want to find the greatest common factor of a polynomial. So what you need to remember is that a common factor is a number that they have in common. So a number that everything is divisible by. So when we're doing this with polynomials, we'll be doing it with numbers and with letters. So the first thing we want to do is we want to find that greatest common factor. So we want to find the greatest common factor. We're going to call it GCF, find the greatest common factor. There's a couple of ways to do this. We can use prime numbers, and I'm going to do it mostly using prime numbers or prime factors. And we can also use it if you just happen to recognize that something has a greatest common factor, then you can just use that number. You don't have to use prime factors. So to use prime factors, we're going to find a prime number. Find a prime number that equally divides into everything. And that's the key, equally. And we're going to do this very similar to the setup that we use when we're simplifying radicals. We're going to take this entire polynomial, 12x cubed plus 9x plus 3. And we're going to look at this. And our prime numbers, remember if you need to make a list, our prime numbers are 2, 3, 5, 7, 11. You might go as high as 13. Not likely. Probably going to stay in this little bitty number range, 2, 3, and 5. So when I look at 12, 9, and 3, I know that 3 is a prime number that goes into all of these. So I'm going to put 3 out here. And then I'm just going to do my upside down division. 12x cubed divided by 3, so 12 divided by 3 is 4, and then I haven't done anything with the x cubed, so I'm going to bring that down. And then positive 9x divided by 3, 9 divided by 3 is 3, and we're going to bring the x down. And then positive 3 divided by 3 is a positive 1. When you find a greatest common factor that is one of the numbers that's in your list, that's in your polynomial, and you factor it out, make sure that there's a 1 there. You've got to have that 1. It's got to stay as a placeholder, because the idea here is that I can take the number that I factored out and I can multiply it times this and get back to that original polynomial that I started with. So to write our answer, we call it the leftovers just because it's the stuff that was left after. So these are my leftovers. They're left after I take the greatest common factor. So the leftovers go in a set of parentheses. And that greatest common factor goes in front of the parentheses. So I'm going to take these leftovers right here, 4x cubed plus 3x plus 1, and I'm going to put them inside a set of parentheses, and I'm going to take that greatest common factor that I factored out and I'm going to put it in the front. That's all you need to do to find the greatest common factor of a polynomial. So let's just work a couple more examples to get a little more comfortable with it. So our second one is going to be 40x to the fourth minus 24. So I'm going to work with prime numbers. If you see the greatest common factor of that just by looking at it, then go ahead and factor that out and save yourself some steps. I'm going to do prime factors though. Both of these are even numbers, so I'm going to start with 2. 40x to the fourth divided by 2 is 20x to the fourth. And 24, negative 24 divided by 2 is negative 12. Still have even numbers, so I can use 2 again. 20 divided by 2 is 10, x to the fourth, and negative 12 divided by 2 is negative 6. Still have even numbers, so I'm going to use 2 yet again. And 10 divided by 2 is 5x to the fourth, and negative 6 divided by 2 is negative 3. These are prime numbers. 3 and 5 are prime numbers, so I can't go any further because they don't have anything in common. They don't have any prime numbers in common because they're prime numbers. So I'm going to take my leftovers and I'm going to put them in a set of parentheses. And then I'm going to take everything that I factored out and I'm going to multiply those back together. 2 times 2 is 4 times 2 is 8. So my greatest common factor is 8. So that's going to go outside my parentheses. So if you factor out multiple, meaning more than one, multiple prime numbers, do exactly that. Multiply them back together. And that will give you what your greatest common factor is to put outside your parentheses. Now, both of those examples are dealing with just the numbers. This is algebra. It's not just numbers anymore. Now we also deal with variables. So let's look at a couple of examples using these same two steps of finding the GCF using prime factors and using the leftovers to write our answer. Let's do this with a couple of problems with multiple variables in them. So I've got 90x to the third. Actually, this one doesn't have multiple variables in it. I'll put some in it. Plus 50x squared plus 10x. My original problem didn't have all those x's in it. All right, so what we want to do is we want to first find the number that they have in common, that greatest common factor that they have in common. Now, when I look at this problem, I'm going to go ahead and rewrite it. When I look at this problem, I know that 10 will go into all of those numbers. So instead of doing the prime factorization for all of this, I'm going to factor out a 10 because I know 10 will go into all three of those. 90 divided by 10 is 9. Bring down the x to the third. 50 divided by 10 is 5. Bring down the x to the second. And 10 divided by 10 is 1. We're going to bring down the x. Now, when we work with variables, what we want to do is look for the variable with the smallest exponent. So let's make some notes over here. When we're dealing with variables, find the variable with the smallest exponent. That is the GCF of the variables. So x to the 1, just this x right here, this is the variable with the smallest exponent. So I'm going to factor that out. And 9x to the third divided by x, the 9 stays the same. There were 3 x's here. I factored one of them out, so now there's 2 x's. So it's x squared. The 5 is going to stay the same. X squared divided by x leaves me with an x. So I got 5x. And then there was 1 x here. I factored it out, so that left no x's. It just left that 1 by itself. So we're going to take our leftovers, 9x squared plus 5x plus 1, and we're going to put those in parentheses. And then we're going to take what we had outside, and we're going to multiply that together. 10 times x is 10x. So our greatest common factor for that problem was 10x. So a couple notes here on the bottom, and we'll go do one more example. A couple of notes here. If you recognize the GCF, you don't have to use prime numbers. If something factors out completely, like here, this 10x factored out completely, it doesn't disappear. So if something factors out completely, it does not disappear. You have to, there's still a 1 there. Because I don't want it to disappear, because I should be able to take this problem right here and distribute 10x times 9x squared will take me back to 90x to the third. 10x times 5x will take me back to 50x squared. And 10x times 1 will take me back to 10x. So I need that 1 there, because if that 1 were to just disappear, if you were to say, well, I factored that out, it's gone, when you went back to multiply and check your answer, you wouldn't get that 10x on the end because you didn't multiply by 1. So you've got to make sure that things don't completely disappear when you factor them out. They just get replaced with a 1. So there's still a 1 there. Let's look at a couple more examples with variables. So the first example, well, technically the second example that we're going to do with variables is going to just be nothing but variables. So x to the 7th plus x to the 5th. 5 is terrible. X to the 5th plus x to the 3rd. So we have x's all the way across, x, x, x. This one has the smallest exponent. So when we go to do our work, that's the one we're going to factor out. We're going to factor out x to the 3rd. So we started the first monomial here is x to the 7th. X to the 7th divided by x to the 3rd. If you use the rules of exponents, it says if you divide, just subtract the exponent. So 7 minus 3 leaves me with x to the 4th. Plus x to the 5th divided by x to the 3rd. 5 minus 3 leaves me with x squared. And x to the 3rd divided by x to the 3rd leaves you with a 1. Doesn't disappear, just leaves you with a 1. You got to have it to hold the place so that when you rewrite your work into an actual problem, it will create this multiplication, this distribution will create this original problem. So when you're working with the variables, always just look for the variable. Make sure there's a variable everywhere. If they don't all have a variable in common, let me go back to the front here. They don't all have a variable in common in our first couple of examples. They have variables, but there's not a variable in all 3 spots. If there's not a variable in every place, then you can't factor out a variable. They don't have a greatest common factor. So that's the first thing. Make sure there's a variable in every term. So if we had 29x to the 5th minus 17x squared. I'm going to go down here to do my upside down division, and I'm going to realize there's nothing that goes into 29 and 17. Those are actually prime numbers. So all I'm going to worry about are the variables. Here is the variable with the smallest exponent, so that's what's going to come out. 29x to the 5th divided by x squared. 29 stays the same. 5 minus 2 leaves me with x to the 3rd. Negative 17x squared divided by x squared. 17 is untouched. X squared divided by x squared technically becomes a 1, and I can put times 1 there, but it's not necessary. So that's a case where it just looks like it disappeared. It didn't disappear. I took that 1 that it turned into and multiplied it times that 17. So 29x to the 3rd minus 17, and my greatest common factor is x squared. So use prime numbers. Use all of the factors that you know. If you know factors that aren't prime numbers, you can use those. If you recognize the greatest common factor from the beginning, go ahead and take the greatest common factor out from the beginning. When you're dealing with variables, look for the variable with the smallest exponent, and that's what you're going to factor out. And then take whatever those leftovers are at the bottom of your division, put them in parentheses, and take your greatest common factor and put it in front of your parentheses.